The first thing we can notice about each of these square roots, these terms all have a common factor that can be factored out. We also notice that they want the answer written in this format. So let's rewrite these three factors as a, b, and c for 1 minus x, 1 minus y, and 1 minus c. To make the substitution easier, I'm also going to solve for x, y, and z. And let's also create expressions for 2 minus x, 2 minus y, and 2 minus z. This will make it easier to substitute. So now we want to find the square of the product of a, b, c. We'll number these equations and rewrite them in terms of our new variables. Let's continue with the first equation by squaring both sides. We'll square these two terms, and we'll take 2 times the product of these terms, and note that we have a difference of squares factorization. So I'll replace this with 1 minus a squared and 1 minus b squared. Squaring the right side is just 1. We're going to expand some more and collect like terms. We see a lot of terms disappear, and we're left with 2 minus 2ab and the square root. Let's isolate the square root and square again. Squaring the right-hand side, we get 4a squared b squared minus 4ab plus 1. And we'll distribute the 4, and we're glad to see this 4a squared b squared disappear. And we'll collect all the terms on one side. So this is our simplified equation from equation number 1. Let's go back to equation number 2. And again, we'll square both sides. And when we take the product of these two terms, again, we see the difference of squares factorization. And the right-hand side is 2. We'll multiply these out and collect like terms and isolate the square root sign. We have 2 minus 2bc, so the c's cancel and the b's cancel. Now we can divide by 2 and isolate the square root. And we'll square both sides and combine like terms again, and we get this nice equation from equation 2. Let's go on to the third equation, and we'll do the same thing. This time our expression is equal to 3. We'll cancel our terms again. We're left with a 2, and we square again. Right, we're going to get rid of the 4a squared c squared on both sides, and this is what we get from our third equation. At a glance, we can see that equation 1 and equation 3 are pretty similar, so let's combine them. We'll get rid of these 4a squared. We'll get 4 times b squared minus c squared. And if we subtract the second equation, we can factor out a negative 4 and an a, and we're left with b plus c. The right-hand side is 0. We can factor out 4 and b plus c from both of these terms. We have b minus c from here, and then a minus a. Now we have two cases. Either this factor is equal to 0, or this one is. Let's call this case 1. We haven't used equation 2 yet, but to get this simplified equation, we needed to square a couple of times. So I'd like to return to this more original equation over here before we squared. From equation 2, we need the sum of these two terms to be equal to the square root of 2. So let's see what happens when we substitute. Replacing all the b's with c's, this is just 1 plus c, and this is 1 minus c, and we get 2, which is not a valid solution. So we're going to go with this. This is case 2. Since we're pretty confident this is the right solution, we can go ahead and substitute it in for equation 3. I'll rewrite it down here. And we can use equation 2 as well. Our equation 3 here is in terms of a and c, so we can replace this b in our second equation will also be in terms of a and c. We'll expand this square and combine like terms. This will leave us with a 2c squared. I'd like to get rid of this ac term. Let's take this equation and multiply both sides by 2. And we'll replicate this equation over here. This is nice, because now we're going to lose 2 of our terms in both equations, and we're left with 2a squared is equal to 1, and a squared is equal to a half. Let's go back to the problem statement. This gives us 1/3 of our solution. Now all we have to do is find the square of b and c. We can find c if we rewrite equation 3 by factoring out 4c from these last two terms. The c plus a is equal to b. A squared is equal to a half, so this term is 2. Now we can solve for the product of b and c at the same time. And squaring, finding the product, this is 1 over 32. Taking the sum of m and n, our answer is 33. If you'd like me to solve any other contest problems, please leave them in the comments.